Let us solve this question based on the properties of triangles. Now you are given such a relation. What does that mean? PR square minus QR square is PQ square. That means PR square is equal to the sum of the other two sides of the triangle PQR. Which means what? By the converse of the Pythagoras theorem, it means that the angle opposite to PR. What is the angle opposite to PR? Which is angle Q. That is a 90 degrees. This is the converse of the Pythagoras theorem. Now a brief reminder for Pythagoras theorem and its converse. How do they work? If you have any triangle PQR and one of its angles is 90, then its opposite side satisfies such a condition. This is the Pythagoras theorem. Now again, if you have any random triangle and its sides satisfy such a condition, then the converse to the Pythagoras theorem states that the angle opposite to this side will be 90 degrees. So 90 degrees, such a condition is Pythagoras theorem. Such a condition, 90 degrees, is its converse. So usually in triangles, to prove that some angle is 90 degrees, we often use the converse of the Pythagoras theorem. So if this angle, I will name it 1 and 2 and 3 and 4, then what we have proved is what? Angle 2 plus angle 3 is 90 degrees. Now what we have to prove is such a relation holds, or in other words, we have to prove that these two small triangles that you see here, not a big one, these two small triangles, you have to prove that they are similar. Why is that? Why is it enough to prove that those two triangles are similar? Now look at this. This is in such an equation form. Now make it in the ratio form. How do you do that? From each side. Here you have QM into QM and here you have this. From each side, keep one quantity as it is randomly. Keep one quantity as it is, and by cross multiplication, bring the other one here. Bring QM here and MR here. At this stage, check if they make the vertices of a triangle, or in plain English, there should only be 3 alphabets. If you have 4 alphabets, it means there are 4 vertices and it means a quadrilateral. That is not what we are looking for. At this stage, see if you have 3 vertices, and most importantly, see if those 3 vertices form a triangle. QMMR. So QMR, does that form a triangle? QMR. Now PMQM. Consider PMQ. Does that make a triangle? Yes. So if you can prove that these two triangles are similar, then their ratios will be same. From that you can get such an equation. Now sometimes when you cross multiply, when you put PM here and MR here, sometimes maybe it does not make sense. It may be sometimes a straight line, or you are getting maybe 4 vertices. Then no problem. Put PM here and MR here. All you have to do is keep one quantity here, one quantity here, and adjust the other two so that it makes sense to you. It should form a triangle. Now let us prove that these two triangles are similar. Now in these two triangles, one angle is same. At this place, you see both of them are 90 degrees because it is given QM is perpendicular to PR. We just need to find one more angle to apply the AA similarity rule. How do we do that? Now we just saw that angle 2 plus angle 3 is 90 degrees because we applied the converse of the Pythagoras theorem. But then angle 3 plus angle 4 is equal to what? That is also 90 degrees. Why is that? If you consider the triangle QMR, the sum of the angles of a triangle is 180. If this is 90, the sum of the other two are 90. So you have two equations. subtract both of them, and then what do you see? 3 gets cancelled, 90 gets cancelled, and you get what? Angle 2 is equal to angle 3, which means by A similarity, how are the two triangles similar? When you write the similarity, please make sure that the corresponding angles are same. Where you see M, you write M, and where you see Q, here 2 and this 4 are the angles which are same. So in the angle QPM, the place where you see Q, at that place put R, because 2 and R are the angles which are same. And then what is the remaining vertex? Put it here. So actually this is the form where they both are similar. So if these two triangles are similar, then how will their ratio look? Now if this is how the similarity works, then write down the ratio of the corresponding sides. First side here, first side here, second side here, second side here, and then the third one. Once you write the ratios, you will see that this is the required ratio. You will have what? QM square is PM into RM. There we have our required result here.